Hello, hi, shalom. My name is Yair Ein-Eli, and I am the head of the Corrosion and Applied Electrochemistry Laboratory. I would like to speak with you about our research, but before that, just to let you know that we are collaborating with academic and industrial entities, and we are aiming our research specifically into the energy section, batteries and fuel cells, into electrocatalysis in fuel cells, electroplating, and corrosion science. Altogether, we are aiming at the energy field. Now, electric vehicle or electric cars appeared a while ago, but they were not implemented due to several problems. The first one is the range, the price, and the location of the chargers. But here today, we are evidencing a revolution. The revolution is made by the industry capability to produce high power and high energy batteries. Now, take a look. Sustainable energy will surge up to 2050, and most of the energy would come from this source, while by 2050, 1/3 of the cars will be powered by batteries or fuel cells. This must dictate a research and technology development. Now, if you are taking a look at the price of lithium-ion battery, and we'll speak on the technology in a minute, you will see that by 10 years, the price went down from $1,000 per kilowatt hour to less than $50 being anticipated by 2030. Now, if we'll take a look on the anticipation to use electric vehicle, we'll see that by 2030, 2 terawatt-hour are going to be consumed by electric vehicle or electromobility. This is due mainly to the lithium-ion technology, which we see here, where lithium is being transferred from a host to guest for thousands of cycles. These are durable batteries and strong, but yet we have to improve them. Improvement would come from our ability to increase the potential and the durability, sustainability of these materials. We take a look at the atomic layer deposition that we protect the powder, and here below you will see our efforts in order to develop highly flexible 5-volt lithium-ion battery without any metal. So this will play in the background, while you will see in a minute that we also look at silicon, aluminum, magnesium, and sodium as the cornerstone of the anode materials. Why? Because they are abundant, they are cheap, and they are resourceful. Second, we look into new hosting material for the 5-volt cathode materials. We also look at the solid electrolyte versus the liquid electrolyte, and we also try to improve current technologies. As you will see here, we are piling up the stacking of the anode and cathode on CNT, carbon nanotube. And here you will see how flexible they are, and they are capable of delivering the electricity and power to light the bulb. And this is done after really folding here back and forth many times. So we have the ability to produce new battery chemistries and technologies. Now, the second topic is fuel cells. Fuel cells will be here. The question is, in what cost and what kind of durability can we achieve? And we can do it only if we will be able to overcome the problems of fuel cells in durability and cost. So we are looking at the bipolar plates in order to increase their corrosion ability. We also look at the corrosion of the catalyst while sitting on the supporting carbon. This problem, once solved, will allow fuel cells to enter the market of electric vehicle and electromobility. Next, we are speaking about what will happen if all EVs will try to charge their batteries on site. The question is, how do we deliver the current? And ampacity is the term. So our thought is, of course, to try and mimic the brain activity and distribute the current through multi-nano clusters into a one cable. So instead of a river flowing in one channel, we have multi-channels of electricity being flown, and this is what we are doing. This is image of our brain activity down into the cables. Now, what are the topics that within our group? So we're speaking about wires for high electrical transmission. We're speaking about metal air batteries and fuel cells. We're speaking about silicon-ion batteries. This is a new concept that we are trying to push forward. Solid-state electrolyte, anode materials, for example, sodium ion, which sodium is resourceful. we're speaking about 5-volt cathode material for lithium ion, and looking at the surface on a single particle of each battery and to see whether the surface is being monitored and changed during the operation of the battery. Finally, we are continuing our efforts in flexible and conformal battery. Now, you may want to reach me at this email, at WhatsApp as well, or any other communication that you will find suitable. And we also bake sourdough bread. So welcome to the group.